Good morning, everybody. So I'm Fabien Penso. I worked the past 2 years on an indexer, an on-chain indexer. It's mostly used by Stargaze today. And I'm going to try to fit within 20 minutes how I built it the past 2 years and the kind of pitfalls that you have. So as an introduction, so the project name is called Constellation. It's been 2 years of full-time work. It's co-owned by Stargaze and myself. So I started it before, and when I've shown it to Shane, the founder of Stargaze, he was like, "This is amazing. We'll just, acquire it." And I wanted to keep it on my own as well, so it's dual-owned. It's about 77,000 lines of Rust right now, so it's much bigger than people would expect for like an indexer. Are you good with the mic? Yeah. The time to index from Genesis, big blockchains like Osmosis, is about 6 hours. So it's really, really fast. And I don't think there's anything faster available these days. For Stargaze, when you go on Stargaze is actually using Constellations for almost everything when you go on the web version of Stargaze, meaning that if Constellation is down, Stargaze, you won't be able to use Stargaze and buy NFTs. As of today, there's about 15 million requests every day. And Stargaze runs on only 4 servers, dedicated servers. The infrastructure cost for Stargaze is about $600 a month because of those dedicated servers, which when you compare to grants that were given by, let's say, DYDX last year, it was $80,000 a month for infrastructure cost. So the ratio is quite big. It almost makes it feel like a student pet project. And I'm indexing Kujira, Osmosis, Neutron, Noble, and DYDX on the single server because those that don't get massively used, I index them as a proof of concept. They could be used by those chains, but very often they're not. But I'm discussing with some of them so they can get more use. This is the kind of feedback that I get on Twitter about Constellation. People love it because basically any contract that you're going to deploy on Stargaze will be indexed for free, meaning that as a Cosmosm engineer, you get that service and those API to build your product, and it's all included. The kind of benefit that we noticed on Stargaze, so some pages on Stargaze used to take 20 seconds to load because it has to call a lot of RPC nodes, like let's say your profile page that will list all your NFTs. And those went from 25 seconds to half a second, even faster sometimes. So that's the kind of gain you will get from an indexer. I'm actually amazed that not more chains are actually including indexers within their, let's say, product as a free service because it actually enhances the user interface by far. The issue you have these days is that internet has been around for a while, and so users are expecting Web 2 performances on Web 3 projects, and you won't have that if you don't have a very fast, efficient indexer. It won't work. You have a lot of issues. You have very slow RPC nodes. We just saw that with Jesse. It's very difficult to optimize RPC nodes. You also have IPFS data, which is very, very slow. NFTs rely on IPFS a lot. And the issue you have with IPFS is that it's so slow that if you're trying to list a directory, it may time out within 30 minutes. So you won't have any feedback for 30 minutes and it just times out. So indexing off-chain information is critical as well, which is what Constellations is doing. I'm indexing IPFS content. How do you build an indexer? So you have to prepare for chaos because there's a lot of wrong information on chain, like malformed UTF-8 or contract addresses that were sent on transactions that actually do not exist because they got like the wrong chain, testnet, mainnet. There's a lot of things on chain that you have to deal with, which are actually false or fake or wrong information. Constellation was done in Rust. I don't need to give any long story about Rust. Everyone around here usually loves it, but that's not enough. Rust is not enough to make a very performant software. There's a lot of tweaks and performance and weeks and months that I had to spend to optimize that code. So when I talk about indexer, this is usually what people comes with. Like, it's easy. You just you fetch block, you store them, and you get an API. And that's basically what it is, but it's way harder than it seems, and that's why I spent 2 years doing it. So I'm going to talk about fetching the blocks, which is actually a pretty big piece on its own, then storing and a little bit parsing, and what tools you can add on top of Constellation and indexers in general. So the first thing is fetching blocks, which is super hard. There's a lot of chains that actually don't have archive nodes injected. For example, I've been waiting for weeks for archive node, and I don't have them yet. So you have to prepare, like the code just to fetch those blocks is actually really difficult. So my first advice will be to you need to have a config information, and you need to support multiple nodes for the same chain. So this is what you see here is an example. So I'm using Rhino for Stargaze and Notional for all the other except a few archive nodes. And so what you see here is I can define the RPC endpoints of Osmosis mainnet on multiple nodes, because sometimes the archive node is too slow. So you have to get a front node that will only get the last blocks, and then the archive node. So you basically need to support multiple nodes, but you also need to support multiple throttling, because a node may say, hey, I only want to have 10 requests per second, and the other one will be like, hey, you can have 50 per second. You have to deal with the offline nodes, broken nodes, 502s, and all those things. So the best to fetch blocks in a very fast manner is to support multiple nodes and supporting those potential issues coming with it. So how to make it fast? When I fetch blocks from RPC nodes, I'm trying to fetch them as fast as possible, because sometimes it takes a few days to fetch those blocks. So what you see right here, how do you get a laser? Yeah, so here is like, so it's using Tokyo, so I can spawn multiple tasks and do as many requests as I want. Here you have a join set, and then for every block that I'm trying to fetch, I'm going to spawn a task right here and fetch the block, and then wait for all those tasks to finish. What you get with this is a very performant fetching. I can fetch 1,000 requests at the same time, and usually the issues on the other side, and people are like begging me to stop fetching because the load of the server is just exploding. It seems simple, but there's a little trick if you're using Tokyo and async tasks, is that you have to use a join set. Because if you're not using a join set, and if you're using what I did in the beginning, which is a vector to store all those tasks, you will have memory leaks. So basically, your process will take 100 gigabyte because those memory don't get freed. So this sounds very simple, but that is something you really need to use if you want to use multitask on Tokyo and tasks. Here I give another example. I don't know if people are aware, there's a crate called Rayon, which allows you to parallelize in multi-threads in Rust. And what's amazing is that you can basically, if I iterate through multiple blocks to fetch them, which you have here, if I iterate, you just add par iter, which is like parallelize iter, and it will just do it on multi-threads. You can also define the amount of maximum threads that you want to have. I'm not using this. I'm using it for a few things, but if you don't have async and you need parallelism, use this. It's very efficient. I encountered issues with just fetching blocks. Fetching blocks properly took me weeks, if not months, to fix and find all the potential issues. So as I was saying, you have very slow archive node. You have 502 timeouts, some nodes that disappear, so you have to ensure that you can still fetch blocks. Rate limiting on public archive nodes. I had some very weird issue. Two things that were filled up recently is this. So you have invalid sec1 tags on signatures on chain. On I think this one is on Osmosis, for example. So like if I'm trying to get this block, that transaction has an invalid signature. It's not safety related because it's just this sec1 tag. But the issue you have is that the Go SDK does not check those tags, so they go on chain. But the Rust code is very compliant to the RFC, and Tony, who's working on it, is like, oh yeah, invalid tag, use something else. But you have to pass those because I can't fetch those blocks and store them on disk if I can't pass the JSON that I get. So this is ongoing. And there's another one which is there's an issue for DOIDX and say archive blocks with the commit BFT. There's a 3002 issue that was filled, or I cannot get in a transaction results for older block than a few months ago because when they switched commit BFT version, I think they changed the way the interface work, and so you cannot get the events. And that was filled up recently. And those bugs I found, like I found bug weekly, basically when I work on this. And you also have blank validator keys because you have some archive nodes that are running and they don't include the validator key because they don't want to fill any. So there's like a blank one, which is invalid. Again, Rust will complain, and so 5 minutes, oh my God, okay. And some early blocks are really big, like Osmosis early block is like 280 megs. And the proxy that they have between the archive node and to do throttling is just failing. As I was saying earlier, you're dealing with on-chain and off-chain data. You can't trust any of it. You have to prepare for chaos. You have to, every potential error you think you have, you'll have them. Indexing is a very good way to do TDD, so I advise you to do TDD because you know the input, you know the output. This is the kind of test that I write for my own. I'm the only one working on it, and still I do tests, so you can see the test context, which is a macro that I wrote. So here I'm saying, hey, I'm going to write a test on Stargaze testnet. It's going to fill up all the RPC, all the information that I need, and then I'm just saying, hey, I'm going to pass that block and then make sure that that event is there. And that's what I write for all my code. Second thing, storing blocks, then you have to understand all the protobuf files. Protobuf files is a pain in the ass because user of protobuf files, they remove fields after, but that block exists on chain forever, so you can't pass it, and that's a very good example where on the Cosmos SDK I was looking for a message create clawback vesting account. I have to go through the full Git history, find that message, put it back in my own file to make sure that I have it, and they publicize about buff build on the YAML file in the Git, and they're not there. So you can't rely on buff.build to pull those protobuf files as well. So you have to pull from different repo all those files. And so do's and don'ts on the protobuf files, you have to copy all the protobufs in your repo. At first I thought I would just link to existing ones, but because fields disappear, yeah, I can't do that. So I have to copy everything. And then sometimes you even have existing protobuf files, and the fields gets deleted after and replaced with the reserved, so it's not used. But you need it to pass those old blocks, so it's kind of a pain. Then storing SQL, which is supposed to be the easy part, but storing SQL takes time. I tried to store all the DOIDX events, which is like 2 or 3 billion events. It took 10 hours, which I thought was too slow. So I tried to optimize creating CSV files. I created CSV files that were like almost 1 terabyte big because Postgres says load from file as CSV is the fastest, but it's not. So what you're seeing right here is that when I'm storing block, I have to go by 2,000 blocks at a time because then Postgres fails because you have too many at a time. So you have to use transactions, then multiple injection inserts, but it has to be limited and grouped by. I'm also decoding IBC packets. So IBC packets are base64 encoded, and I decode them before storing them in SQL, so the search is much easier. That's something that I would strongly advise you to do. And I'm going to do the same thing with DAO messages. Then you have to process those transactions. So what I do is I create NFT models based on those messages, so you can query them much faster. And I do the same thing with IBC-related events, Stargaze names. I also set invalid events. So some events are invalid after, like let's say I do a bid on an NFT and then it got sold. That bid is actually not invalid, but it's invalid in the sense that on the user front end, I can show that it's gone. And then I fetch off-chain information like the NFT token metadata and IPFS content. Use tracing. This is a very good example. There's a crate for that. I use tracing in every beginning of methods, which allow me to get Jaeger dashboard like this, so I can see where the performance is an issue. This is an example of the Sentry dashboard. So 15 million requests every day. Sentry dashboard, 14 issues because Rust. Indexing speed. So I try to look at indexing speed at block per second. So I could index, this one is like 10,000 block, 10,000 block per second. But when I got lower block on other chains, I actually found out I had the same speed, which is on the right. You can see 150 megabytes per second, which is the data throughput. So if you want to look at performance, it's better to look at data throughput, so you know how fast you go, whatever the number of blocks you have or how big they are. This is the CPU usage while I'm indexing, which is 100% on all cores, thanks to Tokyo and async work. And this is an example on the 7 million requests that I checked on the Nginx log, and you can see there's only 198 errors on the server side, which is very low amount, thanks to Rust. This is Metabase. It's a BI tool, so I added a BI tool on top of the SQL, so users will have Calvin at Stargaze that is able to pull out dashboards like that just using Metabase, which is a free open source BI tool. And this is performance that I get, so the P75 is 8 milliseconds over 90 days, which is pretty low on the queries. And the app desk is 0.99, which is a pretty good number. Try my best. Thank you very much. Try to go fast.
Thank you. Any questions?
Yep.
So I think it's especially pertinent to Stargaze indexing. So every now and then you have to index something not just from block results, but also the state as of that indexing height.
Yep.
You know, for example, like, you know, NFT buy occurred.
Yep.
Some information is probably not in the events, but you need to pull the actual state, which usually if you do this kind of off-chain indexer, you'd have to do, you know, go through an archival node, which is syncing or nothing, right? So how do you sort of deal with those situations?
Yeah. So Constellation is not a state indexer. For sure, I think state indexing is completely different. It's a bit of a pain because you usually have to run your own node, which I don't want to. And so the way I do it, because Stargaze is a permissioned chain, I know what the contract is doing. So what I do is I deduce the state from those messages because I know the contract, and it's actually working very well because there's not that much happening anyway. And it's been kind of battle tested because that's what we use at Stargaze for 2 years. And so as soon as we have issues, we actually find it quite quickly. So I'm trying to deduce through state. That's a little bit what I do for IBC, for example. So I see IBC messages and I create an IBC client table, channels and so on. And so I get those states from those messages. And the end goal with this at some point, I'm very much thinking about rewriting some Go SDK model in Rust. Because I have the messages, I have the output, expected output, and it's very easy to rewrite those in Rust and ensure that the state in the end is the same because I have those blockchains that allows me to double check if my state is the same as their state. So I've been thinking about it, but this is a one-man job, it's a little bit of work. I don't think it's difficult, I think it's time consuming, so it'll probably take a year or two. But that will allow you to go much faster. So yeah, the answer is that I'm not doing state indexing, but I deduce the state from the messages that I'm seeing on chain.
But how scalable is that? Like for something like Osmosis, a lot of what we do is a lot of state indexing, especially if we need to know like, you know, order book history and like price history and all that kind of stuff.
No, I think it's pretty scalable. I think it's very much faster than anything else. The thing let me give you an example. For that state indexing, let's say for NFT states on Stargaze, which is what I'm doing right now, I'm able to parallelize it per NFT because I can fetch all those messages related to that NFT, and so I can do one thread per NFT. I could do the same in Osmosis with pools. If I want to have the state of pools, I could do multi-processes per pool because I know they don't override. So I can actually parallelize stuff that you can't parallelize in other ways. So my expectation is it's pretty scalable and much faster. That's how I indexed so fast.
Other questions?
On the protobuf point, where you said you have to copy over all protos that ever existed. Have you thought of some kind of like standardization across chains where maybe the chain itself has some kind of config file that says this height means, you know, this is what you check out, and that way it's not like you have to like sift through manually on every one. Like, what way to make it more expandable have you thought of? Because it seems like that's just a big pain.
Are you asking if the chain is diverting from another chain for the same protobuf?
Well, like for instance, on Osmosis, right? Like we've changed our protobus throughout multiple things, and you're seeming like you saying that you have to pull every upgrades protobufs in order to like query
I need the protobuf to include all potential fields that I'm seeing, even for old blocks. If a protobuf is changed over time, then you're kind of screwed for sure. So
what I'm saying is maybe you could create some kind of like standardization across chains where there's a config where you say, okay, at this height, you check out this, and then you use those protos, and then everyone will be able to utilize these much easier, it seems like.
It's a good idea, but the issue is I never know if those protobuf will disappear from those GitHub, because I've seen that as well. So it's like, I can't rely on the outside. It's a good idea. I tried to do that at first. I had a config file where I will link to repos and commits or buff that build if they existed, and I ended up having issues. And the easiest was just to create my own protobuf, which is like a merge of everything I'm seeing. Usually it's very easy. It's just like git clone and copy. But then at least I have the hand on it if I need to change things. Some protobuf have optional fields which actually are not optional, for example. So it allows me to change things a little bit, and it's been working well so far. But the protobuf is such a pain, for sure.
I mean, on the chain registry, we do actually keep like, for what block height, which code version. Maybe we can start to store protos on chain registry as well.
Yeah, but to his point, I think, okay, yeah, never mind. I think I'm taking too much time.
Dylan?
I was curious you made like a unique decision of modeling it through like the use of an NFT.
Yeah.
What was that deciding factor?
Because I started to use it on Stargaze, and Stargaze is an NFT marketplace.
And then could you extend that then, and then I guess use that same model and extend it further and further and further out?
You mean for like other type of models,
right.
like pools and DeFi?
Right.
Yeah, that's what I'm doing right now. My goal by the end of the summer is to have way more features for DeFi stuff and meme coins. So I'm going to index token factories and stuff like that. I started with IBC, where you have IBC hashes, which you don't really know which denom it is. What I do on Constellation is that I'm actually parsing those hash, and on the API you get the real denom and also the USD value at the time of the event, which allows you to summarize USD values over time. So it was the beginning of the DeFi stuff, and so I'm going to extend it. And what you saw with IBC and NFT will be applied for DeFi, like pools and meme coins, where I have models that will allow you to store things faster.
Cool. Thank you.
Thanks.
Any more questions?
Thanks, guys. I'll be around if you have more questions.